Hello everyone and welcome to the 41st edition of MyDBOps MyWebinar. This is Shiny from MyDBOps, your host for this exciting webinar, and we are really happy to have you all here today. I'm very honored to represent a company contributing to the open source database community. Thank you all for your support in our journey so far. Before we dive into our topic, let me give you a quick overview of who we are. MyDBOps is a leading database management and consultancy provider founded in 2016. Over these years, we have had the pleasure of assisting over 800 happy customers. We specialize in providing comprehensive consulting and managed services for a wide range of databases including MySQL, MariaDB, MongoDB, Postgres, TiDB, and Cassandra. Today's topic is something that many database teams and cloud architects deal with, choosing the right MySQL service on AWS. Why is this an important discussion? Well, MySQL is one of the most widely used databases, and AWS makes it easy to run MySQL in the cloud. But the challenge is that AWS gives you multiple ways to do it, each with different pricing, scalability, and availability features. Of course, AWS offers multiple options like RDS MySQL, RDS Multi-AZ cluster, Aurora MySQL, and Aurora Serverless. Each of these has its own strengths and trade-offs, and picking the right one can have a big impact on performance, cost, and high availability. For example, if you need a simple managed MySQL setup, RDS might be enough. But if you want higher availability with faster failover, the new RDS Multi-AZ cluster could be a better choice. Also, making the wrong choice can lead to higher cost, performance issues, or downtime risk. So that is why we are here today to help you make an informed decision. This session is being recorded and the recording will be shared with you later, so you can revisit it anytime. Please use the chat box for any questions or comments. Our team will be monitoring them throughout the session and you will get the answers immediately. And we are joined by Mahalakshmi from IDBOps, an expert in MySQL and cloud databases. She will take us through a deep dive into these AWS MySQL solutions. Our speaker will compare these AWS MySQL services based on architecture, storage, replication methods, failover handling, performance, and cost. So this will help you decide which one fits for your business needs. So without further ado, let's welcome her. Over to you, Mahalakshmi.
Thank you, Shiny, for the introduction. Hello, everyone. It's so happy to see all of you here. As you all aware of our webinar topic, which is AWS MySQL Showdown, RDS versus Aurora versus Serverless, I'm going to help you choose the best MySQL database solution that Amazon offers based on your business needs. Here you can see our agenda of this webinar, where I'm mainly focusing on comparing the AWS MySQL database solutions with respect to architecture, performance, cost, high availability, and replication mechanisms. Let me help you walk through the abstract of our webinar. Amazon Web Services, AWS, you might have all heard of it. It came forward with an Indeed help to let you carefree by managing your MySQL database in cloud. But they offer different types of services to manage your MySQL database, say RDS, Aurora, or serverless. Of all these managed database solutions, how can we opt the right one? So here I am. As I said, I will help you choose the right database solution for your business requirement. I'm going to break down all the differences in these managed services where I will compare architecture, performance, cost, and whatnot. That helps you to decide on your choice. The first comparison of these managed database services is architecture and storage design. Till now, we segregated the AWS MySQL database services into three. One is RDS, the other is Aurora, and then serverless, where in RDS itself we have three subcategories. One is single AZ, the other is multi-AZ, and finally RDS multi-AZ cluster. In this slide, what you are watching is about RDS MySQL single AZ deployment, where only one database instance is available in a single availability zone. That means this single primary instance alone is responsible to handle both the read and write traffic of your business application. See if there is an unintended circumstances happening in the availability zone where your database instance resides, then all your data is lost. And if you need to bring up the database, you have to do a manual failover. For you people, you can choose this type of RDS single lazy for your testing or development kind of purposes. It is not at all recommended to choose this AWS database service for your production environments. Now let's talk about the next advancement or feature of AWS RDS MySQL. Comparing this multi-AZ standby mode feature with RDS single AZ, this one is a way to go because in this deployment, AWS maintains your database in two different availability zones. The data is replicated using synchronous replication, so we don't need to worry about our data. Even in case of a failover, AWS automatically perform the failover to a standby instance in another availability zone. Even with this RDS feature, there is a drawback. That is what the standby instance is promoted to primary during the failover process. While during the process, the read traffic cannot be handled by the standby instance. So if this limitation is okay for your application, then probably I suggest to use this RDS multi-AZ standby. It is not that we can settle out here. We have more interesting features added on the AWS managed database services. In RDS itself, along with single AZ, multi-AZ standby, we have another advancement, which is multi-AZ RDS cluster. In this cluster setup, AWS maintains your write or database instance in one availability zone and the other two reader instances in the two different availability zones. Here your data is replicated using semi-synchronous replication as it's a cluster setup. So you can be assured of your data consistency. If in case of a node failure, as in multi-AZ standby feature, AWS perform automatic failover if your primary instance fails. People who need both high availability and better read performance can go with this RDS multi-AZ cluster. Now that we covered the architecture of RDS MySQL, and some of you might have already pictured to choose RDS going with the features that needed for your application. But choosing the right storage type for your RDS services benefits you to balance performance and cost. AWS RDS is offering four different storage types: GP3, GP2, IO1, and IO2. GP3 is the way to go. It gives you customizable IOPS without forcing you to increase storage, making it far more efficient than GP2, which honestly is outdated. The problem with GP2 is that IOPS are tied to storage size. You get about 3 IOPS per GB. That means if you need 3000 IOPS, you will have to provision your database with 1 terabyte of storage, which doesn't make sense. But with GP3, that's no longer an issue. You start with 3000 IOPS by default, even on a small volume, and you can scale up to 64,000 IOPS independently. That saves you both money and storage. If you're considering IO1 and IO2, just remember they are premium high-end options. IO2 gives you the best durability and can handle up to 256,000 IOPS, which is greater from extreme IO intensive workloads. Now let's look at how Aurora MySQL is designed. Unlike traditional RDS MySQL, Aurora follows a cluster-based architecture. In an Aurora cluster, there is one primary instance that handles all writes, and you can have up to 15 reader instances to distribute read traffic. This makes it highly scalable for read-heavy workloads. One of Aurora's key advantages is its shared storage system. Instead of each instance having its own storage, all instances share a single SSD backed cluster volume, which is automatically replicated across three availability zones for durability. The storage is also auto scaling. That means it expands up to 128 terabytes of storage without requiring manual provisioning. This makes Aurora a great choice for applications that need high availability, scalability, and simplified storage management even. Aurora Serverless is a bit different from both RDS MySQL and standard Aurora. While RDS and Aurora require fixed instances, Aurora Serverless automatically scales compute resources based on demand. Same like Aurora, serverless also uses shared SSD backed storage that expands up to 128 terabyte and maintains 6 copies of data across three availability zones. The key advantage is that Aurora serverless automatically starts and stops instances based on demand, which is not there in Aurora. Earlier we have seen. So when the database is idle, it pauses compute resources, say CPU, memory, to save you costs and restarts them when it's needed. This makes Aurora Serverless a great choice for unpredictable workload environments where you don't want to pay for running instances all the time. As we covered architecture and storage design of RDS with along with the features single AZ, multi-AZ and multi-AZ RDS cluster, Aurora and Aurora serverless, we are going to see the high availability mechanisms of these AWS services. So before we dive into high availability mechanisms of the AWS MySQL database solutions, let us quickly understand what high availability means. It means that a database remains accessible even in case of failures. This can be achieved in MySQL through automatic failover, redundancy, and replication to minimize downtime. Now let's look at how AWS RDS MySQL handles high availability. In a single AZ deployment, there is no automatic failover as we seen and understood from the architecture itself. Recovery has to be done manually. In multi-AZ deployment, a standby mode, AWS automatically promotes a standby instance within a failover time 60 to 120 seconds, but the standby cannot handle reads until it is promoted as primary. In multi-AZ RDS cluster, it offers even faster failover, usually 35 to 50 seconds, that improves your application downtime. Each option provides a different level of availability based on how critical uptime is for your application. You can choose RDS within this single AZ, multi-AZ standby mode or RDS multi-AZ cluster. Now, talking about Aurora, just like RDS MySQL, Aurora also has built-in high availability, but with some key differences. Amazon Aurora offers automatic failover in 30 seconds. If the primary instance fails, Aurora promotes the most up-to-date reader to primary and updates the cluster endpoint accordingly. This ensures minimal downtime with no manual intervention. Whereas Aurora Serverless handles failures a bit differently compared to standard Aurora. Instead of promoting a standby instance, it takes a more dynamic approach. First, AWS continuously monitors the database, and if an instance fails, Aurora automatically provisions a new one based on the required compute capacity. And during the failout process, existing database connections are temporarily put on hold rather than being terminated immediately. That helps your application by not reconnecting manually. So once the instance is ready, the connections are automatically resumed. This helps ensure a smoother transaction with minimal disruption to running queries. And once the instance is ready, Aurora automatically reroutes your traffic to it by updating the database endpoint. This entire process seamlessly happen in the background. This makes Aurora Serverless a great option when you need high availability but don't want to maintain pre-allocated standby instances like in traditional setups. Let's talk about replication mechanisms in AWS MySQL. Replication plays a crucial role in improving availability, scaling, reads, and ensuring data durability. AWS offers different replication methods across RDS and Aurora, each designed for their specific use cases. Let us break them down. AWS RDS single AZ. In this setup, there is no built-in replication. However, we can add up to 5 read replicas using binlog-based asynchronous replication. This helps scale reads, but there is some replication lag. If the primary instance fails, a manual failover is required. And coming to multi-AZ standby mode, to improve availability, AWS provides a multi-AZ deployment with one standby. This uses synchronous physical replication to keep a standby in another AZ up to date. The standby doesn't serve any traffic as we are talking about since architecture. It's only there for failover to ensure a minimal downtime. And in RDS itself, a multi-AZ RDS cluster, it takes it a further step with semi-synchronous physical replication to two standby instances, which can serve read traffic. This reduces read load on the primary. Additionally, we can use a binlog-based asynchronous replication to create external read replicas. Aurora works differently. Instead of binlog based or physical replication, it uses storage based replication. Your data is automatically split into 6 copies across 3 availability zones, and Aurora replicas read directly from shared storage. This eliminates replication lag and supports up to 15 Aurora replicas. Aurora Serverless follows the same storage-based replication model, but with auto-scaling compute resources. It dynamically adjusts capacity based on demand, making it great for unpredictable workloads. So RDS MySQL is using binlog-based async replication for read scaling and physical replication for failover, while Aurora storage-based replication leverages for both availability and scaling. Um, Comparing with this replication mechanism among these database managed services, Aurora is far more efficient with minimal lag. And choosing the right replication strategy depends on your use case, whether it's rate scalability, high availability, or automatic scaling. Now let's see about the performance considerations of the AWS MySQL database solutions. One of the biggest advantages of RDS is scalability. You can expand storage on the fly with zero downtime. As your data grows, your database can scale without any service interruptions. When it comes to storage, RDS supports SSD backed options, which is GP3, GP2, IO1, and IO2, which we have already seen in storage design of AWS RDS MySQL. So AWS has also worked on performance optimizations. Compared to a standard MySQL setup, RDS delivers twice the write throughput and up to 50% faster read performance, which helps applications run more efficiently. For read-only workloads or read-heavy workloads, RDS offers asynchronous replication with read replicas, so queries can be distributed across multiple instances. This improves responsiveness even under heavy loads. So overall, if we talk about RDS MySQL performance, it provides a solid balance of cost, performance, and scalability, it making it a reliable option for production databases. One of the key improvements in multi-AZ cluster is faster transactions. Unlike the traditional multi-AZ standby setup, this cluster allows up to 3 active database instances to handle traffic. Also, another advantage is lower latency. Since write happen in parallel across different daisies, replication lag is significantly reduced, leading to faster updates and improved consistency. For read-heavy workloads, the cluster can efficiently distribute queries to read replicas. It reduces the burden on the primary instance and improves overall database performance. And in case of a failure, failover happens much faster, typically within 35 to 50 seconds when compared to earlier features, single AZ or multi-AZ standby mode. So it evaluates like a longer recovery time in the standby and single AZ deployment. Behind the scenes, AWS uses synchronous replication across instances in different AZs to ensure strong durability and high availability without sacrificing performance. So, multi-AZ RDS cluster is a great choice for applications that need high availability, faster transactions, and better read scalability. Aurora is designed for high durability and scalability. Unlike RDS, where storage is tied to each instance, Aurora uses a shared distributed storage layer, which automatically replicates data 6 times across 3 availability zones. In terms of performance, Aurora supports up to 2 lakh write IOPS with low latency replication, so it makes a great choice for write intensive workloads. For read scalability, Aurora allows you to create up to 15 reader instances. The best part is that these instances use near instant replication. They stay almost in sync with the primary database to ensure fastest, efficient query distribution. Aurora is also optimized for analytical workloads. It supports parallel query execution, meaning complex queries can run faster by leveraging multiple CPU cores. And when it comes to storage, Aurora is fully auto scaling. It automatically expands up to 128 terabyte as your data grows without any downtime or manual intervention like in RDS. Overall, Aurora delivers strong durability, high throughput, and seamless scalability. So it makes a solid choice for high performance applications. Aurora Serverless is all about flexibility and cost efficiency. Unlike traditional databases, it automatically scales compute resources based on demand, so you are never over provisioning or paying for unused capacity. However, since Aurora Serverless starts upon demand, there might be a slight delay when the database activates after being idle. While this isn't an issue for continuous workloads, it's something to consider for low latency or latency sensitive applications. On the cost front, you are never billed or you are only billed for the actual compute time used. So it's a budget friendly option for unpredictable workloads where traffic fluctuates. Aurora Serverless inherits Aurora's highly durable storage architecture. That means your data is replicated 6 times across 3 availability zones for reliability. Even if case an instance shuts down, the data remains intact and a new instance can spin up as needed. For high availability, Aurora Serverless doesn't rely on traditional failover mechanisms. Instead, it uses storage level replication across AZs, just like standard Aurora, to ensure seamless data availability even if an instance fails. So, Aurora Serverless is a great choice for applications with unpredictable traffic, such as development environments, SaaS applications, or infrequent workloads. Now, let's break down the cost benefit analysis of the AWS MySQL database solutions. RDS offers us two main pricing models um, based on workload patterns, on demand instances and reserved instances. On demand instances is a pay as you go model where you are billed by the hour for compute capacity. It's ideal for applications with unpredictable workloads since you are not logged into any long term commitments. However, costs can add up if usage is high over time. Next is reserved instances. If your workload is more stable and consistent, you can commit to a 1 or 3 year term and receive up to 66% of cost savings compared to on demand pricing. This model is great for production databases that run continuously and need predictable cost planning. So, choosing the right pricing model in RDS depends on how steady or variable your database workload is. If your application has a spiky traffic, I say on demand is flexible for you. If it's running 24 by 7, reserved instances provide long term savings. Aurora offers two pricing models, and choosing the right one depends on how your application handles database operations. I will say one is Aurora Standard and the other is Aurora IO Optimized. In Aurora Standard, this model charges separately for compute, storage, and IO operations. It's a good fit for applications with low to moderate IO usage, where IO cost doesn't significantly impact overall spending. Aurora IO optimized. This is designed for IO heavy workloads such as high traffic OLTP applications. Instead of paying separately for IO as in standard model, Aurora IO optimized model offers up to 40% cost savings when spending exceeds 25% of your total Aurora costs. So, if you ask how would you choose among these two options, if your application has unpredictable or moderate IO demands, Aurora Standard works for you best. But if you're running an IO intensive database, Aurora IO optimized can significantly reduce costs. Finally, let's talk about the cost model of Aurora Serverless. One of the biggest advantages of Aurora Serverless is that it follows a pay as you go model. That means you'll only pay for what you use. There are two models here again. One is on demand scaling, the other is cost efficiency. On demand scaling, Aurora Serverless automatically adjusts compute power based on real time demand. Like it makes ideal for unpredictable workloads where database usage fluctuates. And in cost efficiency model, instead of paying for always on instances, you're only billed for the actual compute and storage resources, whatever you are using. This prevents over provisioning and helps reduce your costs for workloads that don't need continuous database operations. So, to say Aurora Serverless is a flexible and cost effective choice for applications with spiky or infrequent database activity, and it also ensures that you are not paying for idle resources. Now that we have compared AWS RDS, Aurora MySQL, and Aurora Serverless, here is the final conclusion on takeaways. RDS MySQL, I would say it's like a great fit for traditional workloads which need a managed MySQL database with multi-AZ failover and replicas for scaling. On the other hand, Aurora MySQL offers better performance and durability with parallel query execution, auto scaling storage, and up to 15 read replicas. So it's a best choice for performance and scalable applications. And finally, Aurora Serverless, it's the most flexible and cost efficient option as we seen in the cost pricing models. Aurora Serverless is ideal for unpredictable workloads as it automatically adjusts compute capacity based on demand and prevents over provisioning costs. So, which one should you choose? If you need a cost effective managed MySQL setup, go with RDS MySQL, where you will have different storage types. You're gonna select what is the storage type you would require for your application. And if you want better performance, high availability, and scalability, Aurora MySQL is the way to go. And if your workload is unpredictable, where you don't want to pay for idle database resources, Aurora Serverless is the perfect fit. So, the right choice ultimately depends on your workload, budget, and performance needs. So, I have compared the architecture, storage design, high availability mechanism, replication, and cost benefit analysis also for your use case. So, go with these comparisons and choose the right database solutions that Amazon is offering based on your budget plan or performance needs. So if you have any questions, you can drop out them in the chat box.
That was a fantastic session, Mahalakshmi. Thank you so much for giving us such a detailed comparison. So finally, choosing the right AWS MySQL solution depends completely on your workload, budget, and availability needs. If you are still not sure which one is best for you, our MyDBOps team can help with expert consultation. So if you need help with the database performance, reach out to us at info@mydbops.com. And the recording of today's webinar will be available shortly on our YouTube channel. So be sure to subscribe it if you haven't already. If you found this session valuable, don't forget to follow MyDBOps on LinkedIn, Twitter, YouTube, and other social media activities for more expert database insights. Thank you all for joining today's My Webinar. We will see you in the next webinar. Have a great weekend. Thank you.